The code and the slide is available on the web at my GitHub repo, github.com/rlabs. I have created a discussion group for Raspberry Pi enthusiasts, groups.google.com, rpi India. So I want to have a community of people who are enthusiastic about hacking on the Raspberry Pi. We can have questions in between rather than postponing interaction to the end. I think it is best that we have some discussion in between. The Raspberry Pi is a single board computer as small as a credit card. It runs the GNU Linux operating system. Let's first look at the hardware capabilities. I have a Raspberry Pi here. In fact, the presentation itself is running on a Raspberry Pi. There is no netbook here or laptop. This is the device that you are seeing here. It has a Broadcom system as its core, an ARM11 processor running at a speed of around 700 megahertz. System memory is around 256 MB of RAM. Plenty of peripheral options. 2 USB master ports are available. You can see them here. There is a Ethernet port here. You have HDMI video here. You can connect the Raspberry Pi to an ordinary television set. There is a television jack here, audio out. Then we have a slot for a SD card here. The operating system is loaded on the SD card. The system boots from the SD card. The first demo will be, I'll just reboot this. The presentation itself is running on a Raspberry Pi. We'll see the system booting up as the first step. We close this. You can see the system shutting down. The most impressive thing about this board is that it costs only $25. You have a complete computer system for $25. There are two models available, Model A as well as Model B. Model A is $25, Model B is $35. Only Model B is in production right now. You can see Linux booting up. The booting process is over. Let me now log in. We drop into a shell, a Linux shell. If you want a graphical interface, you can run startx. And that brings up the Raspberry Pi's graphical user interface. It's based on a very lightweight window manager. I'll just increase the font size. Those who are sitting at the back, is this font enough? Can you see it clearly? Is that okay? Now, the Raspberry has pretty impressive graphics capabilities. Let us see an example of video playback. We're going to do 1080p full motion playback. Now, please understand that this is a device which costs just $25. It is running the movie Big Buck Bunny. See how smooth it is. Perfect video playback. I've got another demo here. Let's try playing Quake. It's quite amazing that you are able to do stuff like this on such an inexpensive device. And that's the Raspberry running Quake. To get started with the Raspberry Pi, you need to buy a few other components. The power supply is a standard micro USB mobile charger. It should give you around at least 700 milliamperes of current. You need a monitor with DVI or HDMI inputs, or even an old TV set will do. Your operating system will be loaded on a SD card or a micro SD card. You need a USB keyboard and a mouse. With these things, you are ready to get started. There are two main Linux images which we can choose. The first one is, the most preferred one is something called Raspbian. It's a Debian GNU Linux distro that is optimized for the Raspberry Pi hardware. Then we have something called Arch Linux. That's a minimalist Linux distro. Installation is fairly simple. All the images are available from the Raspberry Pi website. Download the image, write it on the SD card, and boot the device. It's as simple as that. It is one of the simplest embedded Linux systems which I've ever seen. It's quite easy to get started with. The original objective of the project was to encourage students to learn computing. We have a keynote today. I think that's the last session. The keynote is by the person who designed the Raspberry Pi, Eben Upton. Now, once you install Raspbian, there are certain post-install steps involved, like resizing the SD card to increase the amount of space allocated. If you want to do a remote login, you can enable a Secure Shell. You can configure the keyboard, reboot, and your Raspberry is up and running. Now, after the first reboot, you can do an apt-get update, and that will bring your Debian system up to date. You've seen the video playback capability. Now, for doing this, I've used a player called OMX Player. The standard video players like VLC, they do not have graphics acceleration. Now, OMX Player uses the Raspberry Pi GPU. That's how you're getting such smooth video playback. The default Raspbian distro has plenty of games written using Pygame, and there's another very interesting game design program called Scratch that's available by default. Then, of course, we can run things like Quake 3. The Raspberry is a standard Linux system. All the programming tools, all the utilities, everything that is available on a normal Linux system is available on a Raspberry Pi. If it runs on Linux, it works on the Raspberry. C, C++, Python, Ruby, more exotic languages like Racket, Haskell, Erlang. Now, all these are simply matter of installing them with apt-get. Just do apt-get install, the name of those packages. I'll just show I have programs written in multiple languages. C code, you compile with normal CC. You can run it. Python programs, again you can execute quite easily. Python is available by default. Programs in more exotic languages like Racket, a version of Scheme. what you see there is a scheme program. Takes some time to load Racket. That's a simple factorial defined in scheme. And even languages like Haskell and Erlang, all these are available. For browsing the web, there are some lightweight browsers. Then Chromium support is there. If you want a web server on your Raspberry Pi, you can think of using a program called Nginx. That's a very fast and lightweight web server. If you want to create web applications, say you want to interface your sensors with the web, you want to control some kind of device with a web interface, you can have programs written in Python and several web interfaces based on Python, like say Flask. Now, the Raspberry Pi exposes a set of general purpose I/O pins. This is a very hackable device. You can do all kinds of electronic interfacing experiments. You see a header here. This header brings out plenty of GPIO pins. Through these GPIO pins, you can do simple digital input output. USART is available, I2C, PWM, all these things can be done. Of course, software support for all these things is evolving. The Raspberry is a fairly new device. As a small demo, we'll see how to control an LED using an I/O pin. The way you access I/O pins on the Raspberry Pi is quite simple. The operating system basically models your I/O pins as some kind of special files under a folder called /sys. Now, by accessing these special files, it's possible to make I/O pins go high, make them go low. I have a simple example here. Now, all these code samples are available on the GitHub repo, which I had shown earlier. What you see here is a very simple shell script which controls one of the I/O pins of the Raspberry Pi. Basically, you are writing values 1 and 0 to a special file, a file under the folder sys class GPIO GPIO14. GPIO14 is the I/O pin number of the pin to which I have connected the LED here. You write a 1, the LED goes high, you sleep for 0.5 seconds. Write a 0, the LED goes low, and again sleep for 0.5 seconds. Do it in a loop and you have a simple blinking LED program. Let's try running it. And you can see the output here. the LED is blinking. Just a few lines of shell script, and you have control over your I/O pins. Now, because the I/O pins are exposed as special files, it's quite easy to write programs in any other language. I have programs in Python, in Racket, and in plain Unix shell. Now, all these programs do the same thing, create a blinking LED effect. This is the Python code which does the same thing. Yeah, it's supposed to be blink.py. So you see the LED blinking. The same stuff written in Racket. A version of the Scheme programming language. If there are any questions, maybe you can ask now itself. You need not wait till the end.
Software applications programs for people who need help. I mean, like you can't first time users or something. Yeah, user guide.
The thing is available as a.
Don't have a user guide or something like.
Yeah, user guide is there.
Some test program.
Yeah, that's there on the web. But I think it is it's a paid document. It's not available for free. But there is fairly strong community support. Plenty of blogs are there, mailing lists, groups. Community is fairly strong. So that won't be a big issue.
I have two questions.
Yeah.
One is, apart from Racket and Shell, Python, how about Perl?
Perl should work. I haven't tried Perl, but it will work because all these things work. Because Haskell is fairly exotic, Racket is exotic, Erlang is exotic, Perl is quite standard, so Perl should work.
Section of LED blinking.
Yeah.
So that with that we can interface to other controls and sensors as well.
Of course.
Actuators. So my question here is, how about programming for real-time response?
That's a bit hard. You want real-time control over an I/O pin. Say you want to measure the transition of a pulse, low to high, high to low. That will be quite hard.
So in that case, could we use any real-time RT Linux or say?
I don't think there are two real-time versions of Linux available. One is RT Linux, other one is RTAI. I'm not sure whether those things will work on Raspberry Pi.
Then in that case, possibly we could scale down to the number of tasks or threads that OS is running, so that our response becomes closer to real time.
Yeah. But all those things are fairly involved. What I'm doing is, the easier solution is to have an Arduino or something like a MSP430 launchpad, a simple microcontroller, interface with the USB port, and do your real-time stuff using these things. We'll see one or two small demos now. That is not what he meant. I suppose what he meant was whether you can measure time periods accurately, whether your system can respond to events in a predetermined.
In a predictable time, right?
Yeah, RTOS. Yeah. GPIO is 3.3 volt. It's quite easy to have some kind of translation to 5 volt. Modules are available. SparkFun has a module for converting from 3.3 to 5 volt. Using Raspberry Pi. Sorry. I have another demo here. Yeah. Raspbian, the preferred Raspberry Pi distro these days is something called Raspbian. It's a version of Debian which is optimized for the Raspberry Pi hardware. it uses the hardware floating point. So what I am using here is Raspbian. That's the preferred version these days. I started off with Arch Linux, but these days I am using Raspbian. Yeah, Adafruit has a distro which has, I haven't used it. It seems to have lots of support for all those GPIO manipulation. Another small demo. Let me first do the demo and then we'll see how it works. Okay, I'm controlling the LED using my hand. It's on now. Off. On. Off. How does it work? Any idea? What is there in my hand? Just a watch, nothing else. But that's a special watch. It's called the EZ430 Chronos. It's a watch by TI. It has a solid state accelerometer inside, a radio transmitter. So basically when you move your hand, the tilt is sensed and that is transmitted through the built-in radio. And I have a small receiver here, interface with the USB port, radio receiver. And I'm running a small Python script which will read from the radio receiver, gets the inclination and senses the crossing point, zero crossing point. Based on that, puts on off the LED. The idea here is that any device which presents a serial interface can be accessed quite easily through, say for example, Python. I'm using a module called PySerial here for accessing the radio. This is the program I'm running. It's a fairly small program which uses a module called PySerial to read from the radio receiver and based on the value received, control the GPIO pins. I have a small microcontroller here. This is the TI MSP430 Launchpad. It's quite easy to program it using the Raspberry Pi. Somewhat similar to your Arduino. Just plug it in to the USB port. If you want to write code for the MSP430, you need to have the compiler MSP430 GCC installed. That's available. MSP430 GCC. That's a very simple program, C program, which blinks the LEDs on the Launchpad board. You can compile this. MSP430 GCC with some options. That's compiled. Now you can use a program called MSP debug. This will write the machine code that is written and run it. So we are now programming a simple microcontroller using the Raspberry Pi For doing real-time operations, it is the easier way is to use something like AMSP 430 or an Arduino. Program it either using your PC or the Raspberry itself and run your real-time stuff on the small 8-bit controller, whatever it is. Any questions? The monitor I have at home is a ViewSonic DVI monitor, and it works perfectly using an HDMI to DVI converter cable.
So when you connected first time, it had no issues?
First time?
First time when you connected, you had no issues?
No, it worked. The thing was, I tried it a few months back. First I tried with the old version of Debian. There was some problem. Then what I did was I tried Arch Linux. It worked perfectly on Arch. I think it's a software issue. There used to be some problems with HDMI to DVI converters, but nowadays I think that has been solved. The recent Debian Arch distros, things are working okay. No problems. You can do streaming with your webcam. It's not easy to demonstrate it now. When you plug in your webcam, it's available as a special device /dev/video0. We can use FFmpeg to read the video stream, broadcast the stream over the network, use a browser and view the stream. Quite straightforward. There's a program called Motion available on Linux. Using this program, it's possible to detect movement. And then you can have some kind of pre-programmed activity. You sense movement, you do certain operations that can be very easily programmed. So these two tools, FFmpeg and Motion, using them you can very well manipulate, do pretty interesting things using video. That's a Kronos watch, EZ430 Kronos. An Arduino can be interfaced very easily. Plug in an Arduino and you get a interface /dev/tty USB0. There is something called a jerk board. This board can be used to extend the I/O capabilities of your Raspberry Pi. You want to control motors, switch relays, stuff like that. You can think of using a jerk board. The thing is, it's rather costly. I think it is not really available in India. Instead, you can have your own interface, transistors, use some transistor relays, build your own interface. That will be cheaper. There's another interesting device. It's called Phoenix XSpice. It's an open hardware device from the Inter-University Accelerator Center, New Delhi, an open hardware product from India. You can use this for doing some interesting data acquisition analysis stuff. Small hardware as well as a fairly interesting software framework is available. This is the Phoenix XSpice. You can very easily interface this with the Raspberry Pi, again using a USB cable. I'll be here for some more time. We can maybe see these things in detail. I'll be here in that workshop, one room is there. People are doing some rather interesting projects. Somebody has built a music synthesizer using the Raspberry. There is work on developing something called FishPi. Now FishPi is an autonomous surface vessel, sea-going vessel, which is planned to cross the Atlantic on its own without any kind of manual intervention, purely using GPS-based navigation. The FishPi has at its heart a Raspberry Pi. You can see the standard stuff like coffee machines. People have started doing fairly interesting things. There are some special distributions. The standard Linux distributions are, one is Raspbian, Debian optimized for the Raspberry Pi. Another one is Arch Linux. There are some other distros. One is a media center distro. It's called Rasp BMC. You can make your Raspberry Pi behave like a media center. It's very interesting. We'll see a demo now. There is something called Qt on Pi, which is a distro for doing Qt development using the Raspberry Pi. Android is of course under development. More recently, Firefox is bringing out its own operating system called Firefox OS. A version is available on the Raspberry. Seems to be working, even though it's in alpha stage. Let's now see Rasp BMC working. Rasp BMC is based on XBMC, the media center software. I'll first power this off, and I'll boot the Raspberry using Rasp BMC. I'll change the SD card used. I'm changing the SD card. That's your Raspberry based media center distro booting up. That's a fairly slick interface. You can go home and create your own media center. That brings the demo to a close.